RHS Precalculus presents Timmy's Trig Troubles, Solving Trig Equations.
Timmy is a trig student who's having quite a lot of trouble in solving trigonometric equations. So he decides to send an email to his professor in which he talks about how he's having difficulty solving the homework assignment.
Hey professor, I was having some issues on tonight's homework. I didn't understand how to do problem number 13. Could you give me some help? Thanks, Timmy.
A while after, he receives an email from his professor.
Dear Timmy, I've received your message and I decided to help you. First, let's start with the basics.
In this equation, we will solve for x. First, add 1 to both sides. Then, divide both sides by 2. By looking at the unit circle, we know that sine x equals 1/2 has the solutions x equals pi over 6 and x equals 5 pi over 6. Because this problem asks for all solutions, the answer is x equals pi over 6 plus 2 pi n, and x equals 5 pi over 6 plus 2 pi n, where n is an integer. This completes our first example. Use these skills in more complicated questions. Now to answer your question. Find theta if the range r of projectile is given by r equals 1 over 32 v sub 0 squared theta, times sine 2 theta. First, we know that r equals 300 feet and v sub 0 equals 100 feet per second. Substitute the variables in the equation with these known values so that it becomes 300 over 1 equals 1 over 32 times 100 squared times sine 2 theta. Now we isolate the sine by multiplying by 32, which gives us 9600 equals 100 squared times sine 2 theta. 100 squared is equal to 10,000. So now to further isolate sine, we divide both sides by 10,000. This gives us 96 over 100 equals sine 2 theta. 96 over 100 can be reduced to 24 over 25. If we imagine sine 2 theta as 2 theta equals x, then it becomes sine x equals 24 over 25. Now we take the sine inverse of both sides so that we can find the value of x. The sine inverse of 24 over 25 is 73.74 degrees. By looking at the unit circle, we can say that we get the same value at 180 minus x, which is 106.26 degrees. Now we replace the 2 theta into x. We have 2 theta equals 73.74 degrees. We can solve the theta by dividing both sides by 2. The same goes for 2 theta equals 106.26. This means that theta equals 53.1 degrees and 36.9 degrees. We should also use the double check by plugging the theta values into the equation.
Hope that helps, Timmy. See you on Monday.